Imagine a factory floor at 2 in the morning. One machine is ordinary, another is a rare, expensive press reserved for the product that actually pays the bills. Then the night shift arrives with a stack of generic jobs, and they sit down at the expensive press because it was free. Nothing was broken. The room was simply available, and available is not the same as appropriate. That is the quiet disaster inside a Kubernetes cluster. The scheduler's job is to place pods on healthy nodes. It looks for capacity. It looks for readiness. It does not, by default, understand that one node is a production island, or a GPU rack, or a machine you are about to drain from maintenance. A healthy node is an open door. Workloads walk through it. The question that keeps operators awake is not, can we schedule? It is, how do we keep the wrong workload off scarce capacity without turning the cluster into a museum? If you lock everything down, utilization collapses. If you lock nothing, a burst of NGX replicas can swallow the node you bought for the one service that cannot wait. This is a story about a lock and a key. The lock lives on the node, the key lives on the pod, and the twist, the one that surprises almost everyone the first time they try it, is that holding the key does not choose the room. It only grants permission to be considered. Before we get to that trap, we have to feel the stakes. Specialized hardware, production isolation, and the moment a node becomes unhealthy. All of that sits on two ideas that look simple and are not: taints and tolerations. The Kubernetes scheduler is an allocator under pressure. Pods arrive as requests. Nodes advertise capacity. The matching problem looks almost polite on a whiteboard. Find a node that can fit the request and is ready to run it. In a real cluster, the whiteboard lies. Nodes are not interchangeable. One might be the control plane, already carrying etcd and the API. One might be a worker you have mentally labeled production. One might be a worker you intend for experiments, nightly jobs, anything that can be noisy. The scheduler does not share your mental labels. It sees CPU, memory, and a set of constraints you have actually written down. So the first conceptual conflict is this: health is necessary. It is not sufficient. A node can be ready, unschedulable only in the weakest sense, and still be the last place you want a random deployment. If you rely on hope, hope loses. Someone will scale a replica set. Someone will forget a node selector. Someone will deploy a test chart into the namespace that happens to have room on the expensive machine. Taints and tolerations exist because the cluster needed a language for refusal, not a preference sticker, a refusal that the scheduler is required to honor, with degrees of hardness you can choose. The node speaks first. It says, "I am marked. Stay away unless you can prove you belong." The pod answers, or it does not. That conversation is the whole mechanism. Once you hear it that way, the syntax stops looking like trivia and starts looking like a sentence. A taint is a mark on a node. Think of it as a sign on a door, written in a strict grammar. Key equals value, effect. Key equals value, effect. That is the entire surface form. The key is the name of the restriction. The value is the flavor of that restriction. The effect is what the scheduler and later the eviction machinery will actually do. Together they are not decoration, they are a predicate. A pod that cannot match this triple is, depending on the effect, blocked, discouraged, or evicted. A toleration is the matching exception on the pod. It is not a magnet, it is a passport stamp. If the stamp matches the sign, the pod is allowed to be considered for that node. Allowed, not assigned, not attracted, not guaranteed. That distinction is the hinge of the entire story, and we will watch it fail in public later on a 3-node kind cluster, when production pods wander onto ordinary machines even after they hold the right key. For now, hold the grammar. The node is tainted. The pod either tolerates that taint or it does not. Matching is not a vibe. It is fields lining up. The key, the value, the operator, the effect. When they line up, the door may open. When they do not, the effect decides how rude the refusal will be. Which raises the next question, the one operators actually argue about. Is every refusal equally hard? The first effect is the one you will use most often. NoSchedule, 2 words that mean exactly what they say, and one thing they carefully do not say. NoSchedule tells the scheduler, do not place any new pod on this node unless that pod carries a matching toleration. New arrivals without the stamp are turned away at the door. They remain pending if nowhere else will take them, or they land somewhere else if another node is open. The tainted node simply refuses the new tenant. Here is the part people miss. Existing pods already running on that node are left alone. NoSchedule is not a broom. It is a lock on the front door. Anyone already inside can keep working. That is why you can taint a node for future isolation without instantly detonating whatever is already there. It is also why a node that looks protected in describe output can still be full of yesterday's workloads. The lock was added after they sat down. In the documentary of a cluster, NoSchedule is the velvet rope. Security at the entrance. No one knew without a wristband. The party inside continues. If you needed the room emptied, you chose the wrong effect. We will get to the effect that evicts. First, you have to understand why a soft refusal even exists, because not every node wants a hard lock. Some nodes only want to be inconvenient. PreferNoSchedule is the polite cousin. The scheduler tries to avoid the node. It would rather put the pod somewhere else. But if the cluster is tight, if the alternatives are gone, if the only remaining chair is in the room with the soft sign, the scheduler may still sit the pod down there. This is not a bug. It is a design for people who hate waste more than they hate impurity. Imagine a GPU node you would rather keep for training jobs, but you would rather run a web replica on it than leave the replica pending while customers wait. PreferNoSchedule encodes that compromise. Avoid when you can, yield when you must. The cost is honesty. A soft taint is a suggestion wearing a uniform. Under pressure, it will fold. If your story is, this node must never run general traffic, PreferNoSchedule is the wrong sentence. If your story is, please don't, unless the cluster is on fire, it is the right one. Notice the tension this creates with the opening stakes. We wanted to protect scarce capacity. A preference does not protect, it nudges. Operators who confuse the two wake up to a production node full of batch jobs that arrive during a scale event. The sign was there. The sign was soft. So Kubernetes offers a third effect, and this one does not merely refuse the next guest, it can throw people out. NoExecute is the hard lock with a security escort. It blocks new pods that do not tolerate the taint, the same way NoSchedule does. Then it goes further. Pods already running on the node, if they lack a matching toleration, are evicted. That is the broom. Maintenance windows live here. So do nodes that have become unhealthy. The cluster is saying, this room is no longer a valid home for you, even if you already unpacked. Eviction can be immediate in spirit, but Kubernetes lets you soften the landing with a field on the toleration seconds. It is a grace period. The pod may remain for that many seconds after the NoExecute taint appears, then it must leave. Think of it as a fire alarm with a countdown instead of a shove. Some workloads can flush, some can hand off, some cannot, and you set the number accordingly, or you omit it and accept a faster eviction. This is also where automatic behavior enters the story. Kubernetes can taint nodes when certain node conditions appear. Not every taint is a human with kubectl. The platform itself can mark a node as a place you should not stay. NoExecute is how those marks become motion instead of a footnote in describe output. 3 refusals then. NoSchedule, no new guests, residents stay. PreferNoSchedule, please don't unless you have to. NoExecute, no new guests and non-tolerating residents are removed, optionally after a counted grace. A perfect boundary still cannot identify who should enter. For that, the pod has to speak. Why would anyone paint a node with a refusal in the first place? The usual suspects are not theoretical, dedicated hardware, a node with GPUs or FPGAs, or a special network card, or simply a larger, quieter machine reserved for production. If general workloads can land there, they will, because the scheduler is trying to be hopeful. A taint is how the hardware stops being a public park. Maintenance. You are about to reboot or replace a disk or drain a rack. NoSchedule keeps new work off the node. NoExecute, if you need it, starts moving the work that is already there. The taint is a statement of intent the scheduler can enforce at 3 in the morning when you are not watching the dashboard. And then the automatic case, node conditions. When the kubelet or the controllers decide a node is not a good citizen, taints can appear without a human ceremony. The cluster is protecting itself. Pods that tolerate those conditions can stay and ride out a blip. Pods that do not are asked to leave. Put those three motives next to the opening image. The expensive press, the night shift. The question was never whether Kubernetes can schedule. It was whether the cluster can express not you, not here, not now, without requiring every deployment author to know the private geography of the fleet. Taints put the geography on the node. Tolerations put the exception on the workload. Time to stop talking in metaphors and walk into a room you can actually describe, a three-node kind cluster. The demonstration begins the way many honest Kubernetes stories begin, on a laptop with kind. 3 nodes, 1 control plane, 2 workers, small enough to hold in your head, large enough to have a politics. The control plane node is not a place for your application pods. It already has a job. The 2 workers look interchangeable at first glance. They are not going to stay that way. One of them will be asked to become production. The other will remain ordinary, and later it will be asked to become explicitly non-production. That last step is the one people skip, and skipping it is how the key fails to choose the room. Verification is not ceremony. You list nodes, you describe them, you read the taints line the way a locksmith reads a door. The cluster either already has marks or it does not. In this setup, the control plane arrives with a NoSchedule taint that keeps ordinary workloads off the brain of the cluster. That is not a flourish. It is the first real taint in the story, and it is doing the same job we will later ask a worker to do: refuse the uninvited. The workers at the start are open rooms, ready, schedulable, tempting. If you deployed now, replicas would land wherever the scheduler felt like, which on a tiny cluster often means both workers, or whichever one had a sliver more room. That is the baseline. The empty rooms that are not empty of possibility. Before we taint a worker, we have to look the control plane in the eye. Describe the control plane node and the taint is waiting for you. A NoSchedule mark. The meaning is the one we already learned, applied to the most important machine in a small cluster. Do not schedule new application pods here unless they explicitly tolerate this taint. That is why your deployments do not quietly colonize the API server's home. The control plane is not merely busy, it is marked. The scheduler honors the mark. New guests without the matching toleration never unpack there. This is also a living example of the existing pods stay rule. The control plane's own static pods and system components are already there, or they tolerate what they must. The taint is not trying to evict Kubernetes from Kubernetes. It is trying to keep your 5-replica Nginx experiment from becoming a roommate of etcd. If you have ever wondered why a 3-node kind cluster reports a worker as the place your app landed, this is why. The brain of the cluster refused you, politely and firmly, with NoSchedule. 1 door closed by design, 2 still open. The story only gets interesting when we close one of those as well, and then, later, when we close the last ordinary door so the key finally has only 1 room left to enter. First, the open worker, the one with no story yet. The workers look boring, and that is the point. You inspect them. One is a blank slate, no production taint, no special plea. It is a node the scheduler is happy to use. In the demonstration, this is the ordinary floor of the factory, the machine that should absorb generic work. The other worker is about to lose its innocence. We are going to write a sentence on it. The sentence uses the grammar you already know. The key is node type. The value is production. The effect is NoSchedule. Spoken as a taint, node type equals production, NoSchedule. After that mark exists, the node is no longer a public park. New pods without a matching toleration cannot schedule there. Pods already on it, if any, would remain, because this is NoSchedule, not NoExecute. In a fresh kind cluster, the worker is empty of your apps, so the lock is clean. Future only. This is the moment the cluster stops being 3 equivalent boxes and becomes a small society. Control plane, keep out unless you are the platform. Production worker, keep out unless you claim to be production. Ordinary worker, still anyone's chair. The next move is not theoretical. It is a deployment. 5 replicas, Nginx. No special story about itself. Exactly the night shift stack from the opening. What happens when it arrives? The command is almost too small for the change it makes. You taint the worker node type equals production, NoSchedule. The node now repels. That is the entire spell. Then you create a regular deployment. 5 replicas, Nginx, no tolerations, no claim of specialness. It is the generic workload, the one that would happily sit on the expensive press if the press were unmarked. Watch the placement, because this is the first payoff. The replicas avoid the production worker. They flow to the ordinary worker, the one still willing to take anyone. In the demonstration, they land on kind worker 2 after kind worker has received the production taint. The names are local to the lab. The geometry is the lesson. Closed door, open door, water runs downhill. Nothing clever happened inside Nginx. The pods did not know they were ordinary. They simply failed to present a matching toleration, and NoSchedule did its one job. The production node stayed empty of them. The ordinary node absorbed the burst. If the story ended here, Taints would look like a complete solution. Mark the special machine, generic work stays off it. You could go home. The story does not end here. The intended residents are about to arrive, wearing the key, and the key, as promised, will not choose the room. Stay with that picture for a moment, because the evidence is the argument. 5 ordinary pods, 1 tainted production worker, 1 open worker. The scheduler's decision is visible in a simple get pods, wide output, every replica on the untainted side. This is NoSchedule as a character, not a flag. It does not argue, it does not warn. It simply omits the tainted node from the set of candidates for any pod that cannot tolerate the mark. The production worker might have more CPU. It might be quieter. It might be the node you are staring at in the terminal hoping something will land. The scheduler does not care about your stare. There is a human temptation here. People taint a node, deploy something, see it land elsewhere, and conclude they have built a production island. They have built a fence with one side. The island is protected from tourists. It is not yet reserved for the people who live there because those people have not even been defined. And when they are defined, they will still be allowed to sleep on the tourist beach unless you fence that too. So the regular deployment is not the climax. It is the control experiment. Generic work is excluded from production. Good. Necessary. Incomplete. Now write the production deployment. Give it the matching toleration. Watch what you expect. Then watch what actually happens. The production deployment looks like the regular one until you reach the pod spec. There, under Tolerations, 4 fields do the entire job. The key is node-type. The value is production. The operator is equal. The effect is NoSchedule. That is a matching passport for the taint we wrote on the worker. Key for key, value for value, effect for effect. Equal means the value must actually be production, not a fuzzy cousin. Apply it. The pods can now be considered for the production node. The door that refused NGX is willing to consider this new group. In a clean mental model, they march onto the production worker and stay there, a tidy island, problem solved. Kubernetes does not share that mental model. A toleration is permission to enter a tainted node. It is not a node selector. It is not affinity. It is not a request to prefer that node. The scheduler still sees every node the pod is allowed to use. The production worker is now allowed. The ordinary worker was always allowed. The control plane is still forbidden. So the allowed set is 2 rooms, not 1. This is the conceptual collision the whole documentary has been walking toward. The lock works, the key works. Together they do not mean exclusive residence. They mean the lock no longer applies to you. You may still sit in the cafeteria. And in the lab, that is exactly what the replicas do. Look at the production pods after they schedule. They do not all huddle on the production worker. They spread. Some, perhaps many, land on the ordinary node, the same floor that already holds the generic NGX. The key opened the production door. It did not close the other one. It did not even lock the pods into walking through the production door first. This is the scene operators remember because it feels like a bug the first time. You did the virtuous thing. You tainted production. You annotated the special workload. You expected a reservation. You received a permission slip. The source is blunt about the geometry. Tolerated production pods can still schedule on regular nodes. Of course they can. Regular nodes have no taint that those pods fail to tolerate. There is nothing to fail. An open door does not check your passport. So isolation has a missing half. You protected production from tourists. You did not protect the tourists' beach from becoming a second home for production. And you did not force production to live on the island. If the ordinary worker has room, the scheduler may use it. If you wanted exclusive placement, you asked the wrong object to do the work. A toleration cannot attract. Only another lock can exclude. The next move is almost symmetrical, and that symmetry is the elegance people miss when they are busy being annoyed. Taint the ordinary worker too. Give it a different value. Make regular stop meaning unmarked. Make it mean marked for everyone except production. Lock both sides. The ordinary worker receives its own sentence. Node-type equals non-production, NoSchedule. Same key family, opposite value, same hard effect. Now the map has 3 closed stories. The control plane refuses general guests. The production worker refuses anyone who cannot tolerate production. The remaining worker refuses anyone who cannot tolerate non-production. There is no unmarked public park left in this tiny cluster. The regular NGNX deployment, if it still has no tolerations, cannot sit on production, and now it also cannot sit on the newly marked ordinary worker. In the demonstration, the sequence is taint, then redeploy, and watch the intended pairing appear. The production deployment still carries only the production toleration. That stamp matches one door. It does not match the non-production door. Suddenly, the allowed set for production pods is a single node. This is the moment the key finally chooses a room, and it does so by elimination, not by desire. Permission plus the absence of every other permission. That is exclusive placement in this model, not a magnet, a corridor with one open door. Redeploy so the scheduler is asked again. New pods see the new taints. Remember NoSchedule? What is already running does not teleport. If you need the current generation to move, you replace it. The lab does that. The story on the screen becomes clean. Production replicas remain on the production workload node. The lock and key system works when you accept what each half actually is. Exclusive placement looks obvious after the fact. Production pods on the production worker. Ordinary capacity reserved for ordinary work or empty if ordinary work cannot tolerate the new mark. The cluster has become a set of rooms with labeled keys instead of a warehouse with a single loading dock. Say the rule in one breath, because this is the sentence worth keeping. A taint repels. A matching toleration permits. Permission is not attraction. To keep a workload on a class of nodes, you must both permit that class and refuse the others, either with more taints or with a separate attraction mechanism the source is not using here. The demonstration used only taints and tolerations. It did not need to. In the wider world, you might add node affinity or a node selector to pull as well as to permit. In this story, the pull is simulated by closing every other door. That is enough to prove the point, and it is enough to run a small production island on kind. Notice what we did not do. We did not use PreferNoSchedule. Softness would have leaked replicas back onto the wrong worker the moment the cluster felt busy. We did not use NoExecute on these workers. We were not evicting residents. We were shaping the future candidate set. The effect matched the intent. That pairing, intent to effect, is as important as key to key. There is one last surprise, and it is about endings. What happens when you take the sign off the door? Removing a taint is a small piece of syntax with a large philosophical payload. You append a minus, the same taint string, then a hyphen. Node-type equals production, NoSchedule, then minus. The mark is gone. The door is unmarked again. Here is the consequence the source insists you see. Removing a taint affects future scheduling. It does not reshuffle the present. Workloads already running stay where they are. The lock comes off the door. Nobody is dragged into the hallway. Nobody is marched into the newly opened room. The next pod to arrive will see a different candidate set. The pods that already unpacked keep their chairs. That is consistent with everything NoSchedule has been telling us. The effect was never a continuous force field rearranging the living. It was a rule applied at admission and, for NoExecute, at the moment a taint appears. Take a NoSchedule taint away and you have not issued an eviction, and you have not issued a migration. You have only changed tomorrow. Operators who expect a taint toggle to rebalance a fleet are asking kubectl to be a choreographer. It is a locksmith. If you need motion, you delete pods, you roll a deployment, you drain, you use NoExecute with open eyes. If you only needed to stop protecting a node, the hyphen is enough, and the quiet that follows is not a bug, it is the model. So what did this knowledge actually make possible, back on that factory floor at 2 in the morning? The primary purpose of taints and tolerations is not elegance. It is control over who may land where when ready is too blunt a word. Nodes restrict, pods request exceptions. The scheduler enforces the conversation. If someone asks you in a hallway or a quiz what these objects are for, the honest answer is they keep pods off nodes that have been marked, unless the pod explicitly tolerates the mark. They are how a cluster says no without deleting the node. They are how a workload says, I know what I am asking for. That purpose is why the control plane arrives pre-tainted. It is why a GPU node can refuse a web farm. It is why a dying node can shed work. It is why a production worker can remain empty of tourists. The purpose is restriction with exceptions, not a fancy affinity. Hold that definition against the trap we watched. Purpose is not the same as exclusive pinning. If the quiz stopped at purpose, you would pass. If production landed on the tourist node, you would still have used the objects correctly and missed the architecture. Purpose plus the missing half. Restriction plus the second lock. That is literacy. Literacy is not the end of the story. The field is still arguing about how hard the no should be. Return to the automatic taints, because they are where this mechanism stops being a lab trick and becomes weather. Nodes develop conditions, memory pressure, disk pressure, a network that is not quite a network. The platform can taint in response. NoExecute on a condition is a storm warning that also opens the doors outward. Pods without a toleration leave. Pods with a toleration and a grace period can ride a short storm. Pods with a long grace or a permanent match have declared that they would rather stay on a sick node than move. That declaration is a product decision wearing YAML. A cache that is local to a disk might tolerate a blip. A stateless replica should usually leave and appear somewhere healthier. If every pod tolerates every condition forever, you have disabled the cluster's immune system. If no pod tolerates anything, a flapping condition becomes a eviction storm, a thundering herd of reschedules, a worse outage than the original blip. So the same lock and key that reserved a production worker is also the language of failure. The effect you choose and the seconds you grant are how you trade isolation against availability when the node itself is the problem. Dedicated hardware, maintenance, node conditions. 3 motives, 1 grammar. The grammar is simple. The judgment is not. Slow down on matching, because this is where a single typo becomes a mysterious pending pod. A taint is key, value, effect. A toleration matches when its key matches, its effect matches, and its operator decides what to do with the value. Equal demands the value you wrote. That is what the production manifest used. Operator equal value production. A different operator exists in the wider Kubernetes surface, one that can ignore value and match on key alone, but the demonstration's contract is equal. Production means production. A near miss is a miss. Effect must match too. A toleration for NoSchedule does not satisfy a NoExecute taint. You can imagine a pod that is allowed to be newly scheduled but not allowed to stay through eviction, or the reverse, depending on what you write. The fields are not a blob, they are a checklist. Multiple taints mean multiple checks. The node can carry more than one mark. The pod must tolerate the ones that would otherwise apply their effects. Miss one hard taint and that effect still fires. This is why I added a toleration is not a complete sentence. You added a toleration for something. The node may have been saying 2 somethings. In the kind story, the production worker said 1 something. The ordinary worker later said a different something. The production pod answered only the first. That incomplete answer is exactly why exclusive placement required the second lock instead of a louder first key. Keys do not get louder, doors multiply. It is worth standing the control plane taint next to the production taint until they look like the same animal in different costumes. Both are NoSchedule, both keep uninvited pods off a node that has another job. The control plane's other job is to be the cluster. The production worker's other job is to be the island. The mechanism does not care about your mythology. It cares about the triple. The difference is social. Almost no application should tolerate the control plane taint. Many applications might tolerate a production taint or a hardware taint by design. If you copy-paste tolerations the way people copy-paste security context, you will eventually tolerate the control plane just to make it schedule, and you will have taught your app to sit on the brain. The grammar will obey you, the cluster will suffer you. So the documentary lesson is not taints are powerful, it is taints are obedient. They will protect a node only as far as you refuse to stamp the wrong passports. They will isolate a workload only as far as you close the other rooms. Obedience without judgment is how a 3-node lab becomes a production incident with better vocabulary. Judgment is choosing the effect, the value, and the second lock. Replay the 3 effects against the factory floor now that you have watched a real placement. If the expensive press is PreferNoSchedule, the night shift still sits there when every ordinary machine is busy. You will get a utilization graph that looks healthy and a production incident that looks like mystery latency. Soft refusal is a courtesy. Courtesy is not isolation. If the press is NoSchedule, new generic jobs stay off it. Last night's generic jobs, if any, keep running. You have protected the future and inherited the past. That is the effect we used on Kind Worker. It matched a lab that started empty and a desire not to evict. If the press is NoExecute, the night shift is walked out. New jobs without a stamp never enter. The room becomes what you said it was, including the cost of motion. Connections drop, cache is cold, disruption budgets tested. Add toleration seconds and you have bought a hallway, not a home. The Kind demonstration chose hard admission without eviction. That was a judgment, not a default you should cargo cult onto a node that is on fire. When the node is on fire, NoExecute is the effect that matches the sentence you are actually saying. Intent, then effect, then the second lock if you need exclusivity. The order matters. The lab's redeploy step is easy to skip in a blog-shaped memory and fatal to skip in a cluster. You taint the ordinary worker. You look at running production pods. They may still be sitting on that worker because they were admitted when the door was open. NoSchedule does not come back later and tap them on the shoulder. The new rule applies to the next binding decision, not to the last one. So the demonstration redeploys. New pod objects, or at least a new scheduling attempt after the old ones are gone. Now the candidate set is the set you meant. Production stays on production. The geometry finally matches the architecture diagram people draw before they understand admission time. This is the same philosophy as taint removal, run in reverse. Adding a lock does not teleport residents out. Removing a lock does not teleport anyone in. The cluster is not a fluid. It is a series of decisions frozen into running pods. If you want the present to look like the policy, you must create a new present. That is inconvenient, and it is also what keeps a live cluster from thrashing every time someone edits a taint. Imagine the opposite. Every taint change as a cluster-wide game of musical chairs. You would never touch a taint during business hours. The model chooses stability of the living over prettiness of the map. Pretty maps are for the next deployment. Zoom out from Kind until the same geometry is a fleet. 100 nodes, 10 of them GPU, 5 of them a regulated production pool, the rest a noisy general ocean. Without taints, the ocean occupies the GPU beach because the scheduler found millicores. With only GPU taints, general work stays off the GPUs, but GPU jobs still splash in the ocean, competing with cron and with that one deployment, someone set to 1,000 replicas. With GPU taints and a second family of taints on the ocean, or with affinity pulling GPU jobs home, the beach is a beach. The Kind cluster was not a toy because it was small. It was a toy because it was complete. Every large fleet argument was already present in 3 boxes: a brain you must not colonize, an island you must protect, a mainland that will absorb whatever you fail to refuse. Sensory scale, because abstractions need weight. A single extra daemon set that forgets a toleration will not schedule on your tainted pool, and that might be correct. A single extra deployment that copies a toleration it should not have will schedule on the pool, and that might be a billing event measured in thousands of dollars of GPU time. The grammar is the same, the invoice is not. That is why the opening stakes were never academic. Available is not appropriate, and appropriate has a price. Back to 2 in the morning. The expensive press is no longer a public chair, it carries a mark. The generic jobs cannot sit there. The jobs that belong have a stamp, and because the ordinary machines are marked too, those jobs do not wander. The factory still runs. Utilization is a choice you made with effects, not a prayer you made at the whiteboard. That is what the knowledge made possible. Specialized and production nodes can be protected. Workloads can receive explicit exceptions. The control plane can remain a control plane. Maintenance can close a door. A sick node can evict what should not stay, after a grace you chose in seconds. The lock is on the node. The key is on the pod. The key is permission, not a homing beacon. The second lock is how permission becomes a home. The quiz answer is the small version of that paragraph. Taints and tolerations restrict which pods can schedule on which nodes, by pairing a node-side refusal with a pod-side exception. The long version is everything you watched fail until both sides were locked. The field is still chasing a live question, and it is the right one to leave you with. How should operators balance isolation, utilization, and graceful response when a node goes unhealthy? Too hard a no, and you strand capacity or evict too fast. Too soft a no, and the night shift is back on the expensive press. PreferNoSchedule, NoSchedule, NoExecute, toleration seconds. 4 knobs. 1 cluster that cannot choose them for you. The rooms are labeled now. The keys are honest. The unresolved wort is the judgment call at 2 in the morning, when a node starts to fail and you have to decide who is allowed to stay in a burning room and for how many seconds.